This is your model, right? This model having two parts. So one is the grid connected PV system. Okay. So this grid connected PV system, that means it going to be generated around 100 kilowatt. Okay. So this is going to be connected to this grid point. Okay. And then this common grid point we have electrical load, and also we are connecting that electric load, we are connecting DVR. So this DVR is separate from battery and the PV panel. Okay. And here you will see that, right? So this PV array having a rating of 100 kilowatt, right? Around 100. And then next we have the boost converter. So this is boost converter. So it going to be operated to 5 kilohertz, and it going to boost the voltage to 500 volt. So here we have to maintain 500 volt. And input voltage is around you will see here, right? The input voltage around 273.5 volt, and then after boosting the voltage will be changed to 500. And also this boost converter, right, going to be controlled by means of the incremental conductance UVT. Okay. So you have to measure two input, VPV, IPV. So based upon VPV, IPV, so we are going to decide the incremental conductance conditions, right? These conditions. So you have to check that dA by dV equal to minus I by V. If dA by dV equal to minus I by V, we need to that means we don't need to change anything in the duty cycle. If suppose dI divided by dV, right? So this one is greater than minus I by V, then we need to increment the duty cycle, or else you have to decrement the duty cycle. Okay. So for that only here we have that block, right, for calculating dA by dV and then I by V. Okay. And finally it going to be processed via pendulum generator. Okay. So next thing is, so here we have that 3-level inverter. Okay. So this is going to be controlled by means of voltage, that means voltage and current control. So in this point we have to measure V ABC1, IABC1. So in this point we are measuring VABC, IABC, and then here we are measuring VDC. Okay. And inside you can see that we have two things. One is voltage regulator. So that means you have to measure DC link voltage and VD is reference. After that you have to process via PA controller. So this will be generate ID reference. And then based upon that bus voltage, right, grid bus voltage, right, you have to convert it into VDQ and IDQ. That means here we are applying that ABCD DQ naught. Okay. So next you have to after converting VABC and IABC to VDQ and IDQ, right, and then based upon this ID reference, so you have to apply feed forward control logic. So this is a feed forward control logic. That means you have to compare ID IQ and ID IQ reference, and then process via PA controller, and then this is feed forward decoupling control, and finally here we will get a control voltage. So next the control voltage going to be converted into ABC form, and then it going to be processed via pendulum generator. So this pendulum generator pulse will be going to control this inverter. Okay. So and after inverter we have that filter and the transformer. Okay, step up transformer. So automatically what will be happen? So whatever power generated from this PV, right? So that going to send to the grid. Okay. So this is a grid point. So grid we are having around 450 hertz, 400 volt and 50 hertz supply. And here we are having that DVR, right? DVR is supplied from the PV and battery. Here PV rating is around 20 kilowatt. Okay. So it's around 19.84 kilowatt, operated at 711 volt, 711 volt, and that going to be connected to the battery. So battery is operated at 610 volt, and then this battery going to be drive this that inverter. So inverter having that concept of TransZSI source, right? Z source element. So here you can see that. So this is Z source. Okay. So battery is connected to this source, and this source is going to be connected to this inverter. Okay. And then this inverter going to be controlled by means of DVR. So here we are measuring the load voltage. Okay. So here we are measuring load voltage, and load voltage, the load voltage going to be converted into that means ABC voltage converted into DQ0, and then it going to be compared with the VDC reference, VQ reference, and it going to be processed by a PA controller. So this PA controller will be generate the control signal. Okay.